All right, now that we've talked about general formula syntax, it's time to address one of the most important topics of the course, reference types. Now, these reference types are what allow you to reuse or recycle formulas in multiple places and across multiple cells without having to manually retype formulas or manually update the references contained within them, which, as you'll soon see, would just be completely impractical. So these reference types are all about helping us work more efficiently with our formulas. Now, by default, cell references are relative. And what this means is that those references will change, they'll shift or slide as the formula is copied or moved to new cells. But here's the thing, you can use a $ symbol to create something called a fixed reference. And you can fix either an entire cell or range by inserting a $ before both the column reference, in this case A, and the row reference, in this case 1, or you can fix just a portion of a reference, like just the column or just the row. And what this does is prevent those references from changing as the formula that it's contained within is copied to new cells. In other words, it locks in that reference or that piece of a reference and prevents it from sliding with the formula. So let's take a minute to illustrate what this really means. Consider a reference in cell A1 that's completely relative by default. If you were to copy and paste that reference or that formula from A1 to C4, notice that both the column and the row shift. A shifts to column C, 1 shifts to row 4. So the entire reference has changed. Now consider a relative column and a fixed row. In this case, the A remains relative, but we've added a $ to fix or lock in the row reference. Now, if that reference were to move down to cell C4, note that the A is still allowed to shift from A to C, but the 1 remains locked in place no matter where that formula lives. Same case with the reverse. If you had the fixed column, but the relative row, now our A reference, or column reference, remains the same, but our row reference shifts from 1 to 4. And then finally, if we have a fully fixed column and row, no matter where that formula were to move, we would always be referencing back to cell A1 no matter what. So quick pro tip here, mastering reference types is far and away my #1 tip for working efficiently with formulas. And I know it probably feels a little bit abstract right now, a little bit confusing, but trust me, if you invest the time to practice these references, which we'll do throughout the course, you'll be amazed at how much time you can save. So with that, enough talking, enough theory about this. Let's roll up our sleeves. Let's jump into Excel. I want to show you some examples of why these reference types are so important. All right, so for those of you who are following along, you can go ahead and open up your Section 2 Formulas 101 workbook and jump to your second tab, Reference Types. And what I've done is just built a pretty simple template for a 10-year financial projection. And we're assuming that we've got 3 different assets here, A, B, and C. I've got made up expected growth rates here in column C, and we're just assuming a starting balance of $1,000 in each of those rows. And the idea here is just to use some basic Excel functions to forecast out what that starting balance would turn into over this 10-year period given our different growth rates. So let's see if we can make this work. Right here in cell E4, we're going to start with the equal sign as always, and we're basically going to say let's take our starting balance and let's multiply that by 1.08 in this case, or 108%. To do that, we'll open up the parenthesis, type our 1 plus C4, which is our growth rate. And that's going to take $1,000. It's going to multiply it by 1.08. And if we're feeling good about that, we can simply close the parenthesis, press enter, and there you have it. Our $1,000 has turned into $1,080 by the end of year 1. Absolutely correct. So that sounds good. Let's go ahead and extrapolate that out to 10 years and see what happens. Well, something kind of funny is going on here, right? Because this is saying that by the end of year 2, we've now generated over $1 million, right? And by the end of year 3, over $1 billion. Year 4, we have, I think that's quadrillion, which is more money than the entire world GDP. So unless you're completely delusional, you've probably realized by this point that something is wrong with our formula. And in fact, we can diagnose and figure out exactly what's wrong using some pretty simple tools. One option is just to double click to edit the formula like so, or you can press escape to get back. The F2 shortcut will do the same thing. And what that's going to do when you're in edit mode, it'll show you exactly what cells are referenced within the formula. And it's nice and color coded so that you can see, okay, I've got D4, which is my starting balance, multiplying it by 1 plus C4 in orange, which is my growth rate. So that looks good. I can press enter or control enter to kind of enter it in place. I'm going to arrow over to F4 and do the same thing. So F2 is going to go into edit mode. And now what's going on here? I'm taking my new balance, E4, which is $1,080, which is correct. But now I'm multiplying that balance by 1 plus $1,000 in cell D4. So multiplying it by over 1,000, which is producing this $1 million number, which is obviously incorrect. So what's going on here is that my reference for my growth rate has slid from C4 to D4 to E to F to G, producing these absolutely ridiculous astronomical values here. And this is why reference types are so important. If we go back to our original function and we say, hey, Excel, don't let column C shift to D, E, F, G, H. My growth rate always lives right there. I want to fix that reference in place. What you could do here is type in right in the formula bar those dollar signs. And what if we fix the whole reference, right? We're always going to point to C4 no matter where this formula lives. And let's press enter. Let's go ahead and drag it out again. And that looks a lot more realistic, right? In fact, these numbers are absolutely correct. And now watch the formula bar as I kind of just arrow through. Our starting balance is shifting, which is what we want, but our growth rate is always pointing back to C4, which in this case is just what we need. So last step here, that takes care of asset A. Let's go ahead and grab this whole set of formulas and drag it down this time to assets B and C. Now, what's going on here? We've got different growth rates, right? Now we want 5% and 2%, but we're seeing the exact same projections in every single row. And same story here, we can diagnose by editing one of these cells, and pretty quickly it becomes clear that the problem is that we're always pointing back to C4 because both the column reference C and the row reference 4 are fixed in place. So all we need to do in that case, let's undo that, is go back to E4 right here, and we can say, you know what, we always want the C to stay the same. No matter where this formula lives, the growth rates are always in column C, but we don't want the 4 to remain fixed. So I'm going to simply remove or delete the reference on the row and only fix the column. Press enter, drag it out. Those numbers stay exactly the same as expected. And now watch what happens. We pull it down. Now we're applying the proper growth rate for each row. So there you have it. Pretty simple example, but a good one to illustrate why reference types are so valuable and how they can help you work much more efficiently with formulas in Excel.